Okay, hello everyone. I guess it's time to start. Welcome to ScalaWAW number 27, our Valentine's edition. Today we're gonna have, as usual, two presentations. First by Kai and Pavel, and then will be networking break sponsored by Sumo Logic, and then another presentation by Michał and Aleksander. This meetup wouldn't be possible without the help of our sponsors, iterators, and Sumo Logic. I invite you for a warm round of applause for them. And now, without any further ado, Kai and Pavel will tell you about Izumi. So, welcome on stage.
Hello, everyone.
Thank you very much for coming. It's really nice to see all of you here. I'm sorry about my voice. I've been talking too much over the last few days, so kind of lost it. So the title of our talk is Izumi Framework, Reinvent Your Productivity with Pure Functional Scala. And this will be a talk about application design and our approach to make it easier and more enjoyable. And once we finish with the slides, there will be a short but impressive demo. And if something isn't clear or you disagree with what I'm saying or you want to ask a tricky question, please don't hesitate to raise your hand, interrupt me, and I will try to answer all the questions as we go. And regardless, there will be a Q&A session at the end. So first of all, let us introduce ourselves. We are Pavel and Kai. Well, he's somewhere around. And we are from Septimal Mind, an Irish software development consultancy. We focus on productivity of engineers and team efficiency, and we are big fans of Scala and purely functional programming. And also, we participate in a variety of open source Scala projects and contribute to them. So if you use modern Scala, most likely you use our contributions directly or indirectly. And if you use ZIO, you definitely have our code in your class path. So, as a consultancy, we help our clients to make their teams productive, and we help them to fight complexity in their software development pipelines. And actually, we create tools for that. And of course, it's important to not try to reinvent everything. So usually we decide to commit to a new tool only if a single engineer can deliver a working prototype in a couple of weeks or less. So before we proceed further, let's briefly discuss what kills our productivity. And essentially, the answer can be reduced to just one word. It's always about complexity. And there are various kinds of complexity, for example, computational complexity. But what makes projects extremely expensive and sometimes kills businesses is maintenance complexity. And engineers often try to avoid complexity by shifting it right, by pushing problem detection into the future and to the next participants of the SDLC pipeline up to the end users. And for example, someone may use a dynamically typed language instead of a statically typed one, and this probably would allow the engineer to deliver their prototype faster. But it will inevitably cause more issues to be found later in production and would extremely complicate maintenance if the code base is bigger than several thousand lines of code. And essentially, the shift left approach, it means that you should try to rectify potential problems as early in the development pipeline as possible. So most of the sophisticated approaches and tools we use were invented to shift problems left, like advanced languages with sophisticated typers, automatic testing tools, acceptance testing, automatic acceptance testing, functional programming itself, and of course formal proofs. So I personally would insist that shifting problems left always pays back, but it isn't always easy. We have many useful and sophisticated tools, but we still suffer from complexity. And often we may prototype an idea in a week, but it might take years to turn that idea into a working product for the end user. And what's wrong? And the problem is things we use, they aren't composable, and it's very hard to integrate them. And approaches which work for programming, they often fail. They often fail for engineering, and in many cases, engineers argue with programmers without even realizing that the argument makes little sense. So essentially, engineering is more about integrating components into robust, maintainable systems, and programming is more about getting separate components done. And finally, let's start with our story. Some time ago, we started working with a company which has millions of users and about 100,000 new installations each month. And when we started working together, we had about 30 engineers, and their backend consisted of about 10 microservices in multi-repos, and some were written in Scala and some in Go. And on front end, we have had several mobile applications, and also we had a complex web portal. And we were using Scala as Java Plus with HTTP and Juice, and also we used C#, Go, and TypeScript in their stack. And a year and a half later, we managed to reduce their development costs by 50%, according to their own conservative estimation. And that number, I know it sounds quite impressive. And essentially, I'm gonna tell you what led to it. You obviously can't squeeze a 50% improvement out of an already great process, and such number appear when you are getting rid of blocker issues. And well, what was that big blocker holding that company back so much? Essentially, late integration, late problem detection, and that was caused by the shift-right approach, shift-right practices we were sticking to. And the actual integration of the product has been happening only in production. So things we observed there were pretty common. We've seen that stuff in many companies, at least up to some extent. Like lots of issues would manifest only after deployment, such as bugs, API and data format incompatibilities between microservices and also between front-end and back-end. And the backend team didn't have enough insights into their product, and it was hard to debug problems after a failure, and it was hard to just observe the entire product at once, because the code, it was spread about 13 repositories, 11 for backend and 2 for operations. And last, it was always painful to bring new people on board. Like a new engineer had to memorize a lot of arcane rituals and set up a lot of software before they might get started. So we might say that the primary problem was lack of real continuous integration. And when I say continuous integration, I mean the full original meaning, forgotten meaning of the term, that is automatic testing of all integrations between components after each change. And it's not about just running the build automatically. Actually, that's just the beginning, because most of our integrations these days, they are with other services that are outside of the code base of the product and or outside of the code base of its particular component, or as we say, a microservice. So the problems I've mentioned are fundamental, and at some level they will always be present in our processes. Still though, we did manage to improve the situation for that team. And what did we do? We introduced our own interface definition language to automatically generate compatible type-checked interfaces for remote calls between all components of the product, microservices, front-end and back-end clients and servers. Sorry about that. So when we added better insights using our own structural logging library. It's called LogStage, and we helped the team set up a better Git flow and to move into a monorepo, which in this case was actually very beneficial. And we have put a lot of effort into improving code quality. We have taught the team purely functional programming and helped them to adopt tagless final style with a Bifunctor effect type across all their code base. And when I say Bifunctor, I mean typed errors, no throwing exceptions. As part of that, we implemented state-of-the-art asynchronous stack traces for ZIO. Previously, using pure FP and asynchronous programming in Scala meant having to say goodbye to stack traces, and that was a blocker for adoption of pure FP for many people and for that particular company, and we just had to fix that. And you probably know that now, now any asynchronous I/O monad, they all have asynchronous stack traces. Well, essentially, it was copied from our implementation. Well, but I believe that the most important items are the next ones. So for the rest of the talk, we'll discuss the things which are underlined on the slide. So we added fast and reliable tests and integration tests, and we reshaped the backend into so-called flexible monolith. Sometimes people call similar things microliths. But we prefer term multi-tenant application. And when I say multi-tenant application, it has nothing in common with multi-tenant products. So a multi-tenant product has isolated contexts for different customers, and multi-tenant application may have multiple entry points and may allow several entry points to be launched together. And essentially, multi-tenant applications were one of the important keys to complete the integration process for that company. And by doing all that, we greatly simplified onboarding for the new hires, and we'll talk about that a bit later. And here is a short summary of everything I said before, of the key problems we faced, and the solutions we applied. And before I proceed further, may I ask you those who use ZIO in production to raise your hands? Just one person, really? So no one uses ZIO here. What about cuts and cuts effect? Okay, that's better. What about Monix? Oh, there is one guy. And does anyone use Akka? Oh, a lot of people actually. Okay, that's unexpected. And what about Scala 3? No one. There is one lucky guy. Okay, good for you. And did anyone try to use GraalVM native image? And did it work for you?
Yeah, actually, for my company, it worked pretty well.
That's great. Okay, that's interesting. So, let's continue. Most of our efforts were condensed into our own little framework named Izumi, consisting of 4 loosely coupled key libraries: Bio, LogStage, IdeaLingua, and DIStage. And Bio is a set of cut-styled composable type classes for Bifunctors and Trifunctors with ergonomic summoners. LogStage is a structural logging framework which can extract structure directly from your string interpolations without any additional effort. And IdeaLingua is an ergonomic interface definition language and remote procedure call framework, just an alternative to ergonomic alternative to gRPC, protobuf, and things like that. But that's a subject of a totally different talk. And DIStage is the most advanced and most powerful dependency injection mechanism out there, and in fact, a lot more than that. It's a lot more than just a dependency injection mechanism. And I have to stress again that Izumi is loosely coupled. That is, all its components may be used independently. For example, you don't have to use Bio if you use DIStage. So let's consider all the components. Bio provides you a robust set of abstractions. abstractions. Sorry. So Bio, it provides you a robust set of abstractions which you may use to make your code cleaner, separate concerns, and get all the other benefits of tagless final style. And well, the guys who use Akka, have you at least tried to look at cuts and tagless final style? Yeah, but for some reasons you didn't adopt that. And do you think it's something good or something bad? No one knows. Okay, fine. Essentially, well, trust me, tagless final is one of the greatest things around there. You might get a lot more productive with it if you use it properly. So our Bifunctor type classes, they have ZIO and Monix implementations, and Trifunctor ones, they rely purely on ZIO at this point. And well, Bio, it cleans up your code by providing you a magic effortless summoner for type class methods. So if you didn't like cuts styled TF because of some additional verbosity, you might want to try Bio because it's just a lot easier to use it because of the summoner. And essentially, that summoner, it means that only the methods of type classes which are in scope will be visible in your IntelliSense hints, and at the same time you don't have to make any wildcard imports, you just explicitly import what you're going to use and everything will work. Now, log stage, it makes it easy to have structural logging. You just write your regular string interpolations, and you might turn your textual logs into JSON with one configuration flag. So do you think it is impressive? Okay, no reaction. Well, does anyone actually write structural logs? What do you use for it? Some custom implementation. Yeah, but is it effortless? Do you have to write codecs, do some magic rituals to make things work?
Few extra parameters to the message and that's it. So we have a number of parameters, typed parameters.
So you have to provide parameters separately.
Right.
All right. Well, with style is a lot actually easier to use. You just write regular string interpolations and everything works.
But then you have like a high cardinality for these parameter values, right? For parameters names.
Yeah.
And when you are like indexing the parameters in your log collection framework, the high cardinality may like produce a lot of in memories, like take a lot of capacity on your storage, right?
Well, essentially, yes. So far it wasn't a problem. Well, and actually there was a telecom giant in the US, and well, we tried it, and it allowed them to deliver their text routing, text message routing system a lot faster. We were pretty happy about log stage. Well, let's continue further. DIStage, it's hard. It's something hard to explain on one slide. I'll try to do it in 7 slides. So it's a library which solves all the aspects of the wiring problem. And you know what is wiring and what is dependency injection, right? Okay. So DIStage obviously does dependency injection, and it makes it easy to write multimodal configurable applications which can switch between different component implementations in sound manner. And the DIStage allows you to stop choosing between monoliths and microservices. So now you can write monoliths which have all the good properties of microservices and write microservices which can be run together as a monolith. And it makes setting up test dependencies effortless, and it can soundly share dependencies between tests. And also it can manage external dependencies of your application and Docker containers. It's essentially it may work as a replacement for test containers. Just in case, do you use test containers? Okay, 1, 2, 3, 4 people. Yeah. So we call it scene management. I'll talk about it a little bit later. And DIStage can do all these things without Java reflection, and it works perfectly under native image. It works on Scala.js, and it works on Scala 3. And also it provides you strict compile time checks. So, like many people said that way, no, what dependency injection is, and essentially it means that you just somehow throw recipes of your component declarations together, tell your magic framework what you need, and you magically get an instance. And DIStage, it can do more. So, well, let's walk through an example application. So there is a repository interface with a dummy implementation and a production implementation. And also we have a service that uses the repository and an application entry point that uses the service. And as a side note, when I say dummy, I mean a handcrafted test implementation of an integration point. Dummies are alike to automatic mocks, but they are not auto-generated. People also call dummies fakes and manual mocks, or just mocks. So all the components and their implementations here, they are defined declaratively. And as you can notice, there are two possible implementations for the repository. And when we want to run our app, we have to provide an instance of activation. And activation is a list of flags that tell our application which implementations it should select for this particular run. So actually, if we provide activations through command line, our applications will be multimodal. And as another note, I should mention again that DIStage provides you full compile time correctness checks. It can also wire code written in tagless final style, and it has embedded support for ZIO and cuts effects, and actually there are some useful things for those who use Akka. And of course, DIStage may wire plain code which does not use IO monads and TF style at all. Now, DIStage allows you to set up your test dependencies effortlessly. So in this example, we have an abstract test suite, and each test is a function with arguments, and each argument declares a test dependency. And when we define several so-called environments, each environment defines a test suite configuration. So in this example, we define dummy for tests with dummy repositories, and proden for tests with production repositories. And when we extend our abstract test suite with our environments, that's it. And now our tests are not just wired automatically, but they are also multimodal. We may run the same abstract test suite against different implementations of our integration points. And we call such approach dual test tactic. And it has multiple benefits. So it allows us to draft our business logic quickly without being distracted by aspects specific to our integration points, and it enforces solid design. You have to create better abstractions. So it makes the code more readable, easier to maintain, and it simplifies onboarding for new team members. There will be more on that later. And some people say that testing with dummies is inadequate because it does not reveal problems specific to real integration points. and that is true, and that's why we promote dual tests. And I'm wondering, does anyone here actually does this? Do you use dual testing? So you always test against production implementations. I see. Well, better than nothing. DIStage also supports memoization. So in this particular example, we declare DB driver to be shared across all our tests in actually all the test suites of an artifact, not just this single test suite. And as you can see, it's very simple to do that, and it works very nice. There are no any kind of global variables or shutdown hooks involved, and the DB driver it will finalize immediately after all the test suites finish. So now let's talk about multi-tenant applications. Essentially, a multi-tenant application is an application which can run several so-called roles. And there is a code snippet showing a role definition. And role, a role is just a replacement for a main method. But unlike main methods, there may be several roles in one process, and they may run at the same time. And every role may have its own command line. So usually each role runs as a fiber. So you may think that a role is a microservice, but it's possible to run that microservice in one process with other microservices, if you wanted. And roles way allow us to easily run multiple components or multiple microservices that compose our product in a single process for either simulation or to simplify deployment or to increase computational density of our deployments. As I said before, we use term multi-tenant applications for applications that can run multiple roles. And on the bottom half of the slide, there are two examples of running a multi-tenant application from command line. So the first line would run two roles, users and accounts, with real prod integration points, repo prod and transport prod. And second one would run them with dummy repositories and dummy transports, which may be very useful for quick simulations, which are crucial for real continuous integration. So roles, they are extremely important because combined with dummies and multimodal DI, they allow us to instantly run perfect simulations of a whole product with a single command on a single machine. And this, for example, allows front-end engineers to instantly launch and reset their individual perfect product simulations. So there is also concept we call integration checks, and they allow you to define a simple precondition check which would prevent your tests or your application from starting if a check returns false. And there is a code example on the screen defining an integration check, and as you can see, it's pretty easy to do so. So integration checks, they run before all the startup actions. They provide you very fast feedback and allow your application to fail as early as possible if an external dependency is missing or broken. Or in case of tests, it allows you to skip those tests that can be run without an external dependency and still run the rest. And they also help you to implement dual test tactic when you test business logic twice, first time against dummies and second time against real implementations. And Also, skipping the tests that can't run without external dependencies, it also simplifies onboarding, because someone starting with a project doesn't need to set up all the parts of the environment before we can start hacking and testing the code. They may just clone the repo and start immediately, experimenting immediately. So, and the last concept I'm gonna talk about is scene management. So essentially a scene is a pre-configured environment and an actor comes there and performs. And we may use this metaphor to describe our applications. So we may call the environment where an application runs a scene. And an application may provision its external dependencies on its own. For example, it may run Docker containers. And if it does so, we would call it a managed a managed scene. Or the application may expect that this scene should already be prepared by someone, and we call it a provided scene. And as I said before, DIStage can automatically manage Docker containers for the tests and the application itself. So we briefly discussed many features of Izumi Framework, which allowed us to achieve hyper productivity and cut development costs by half in one particular company. And it allowed us to make that company happy. And now let's have a look at how all this stuff looks in practice. So I'm gonna step back and Kai will show you the actual code.
Is it on?
Where is the other one? Here. Okay. What? What's up? Yeah.
Is it on? No.
Maybe. Okay, I may just give you this one. 1 second. Yeah. Like that.
Okay, does it work? Great. All right. Yes. Mm-hmm. Yeah, something's happened. All right.
There is no picture yet. Just.
Yeah.
Yeah.
Hi. My name is Kai, and I'm going to show you a few of the features Paul talked about in the live session. Is it on? It's not on.
That one is just for live streaming, but I guess I'll have to do it like this.
Wait, why? Wasn't there a stand?
That one is for the questions. But can you hear him? Yes.
Okay.
Can the people in the room?
Right.
Oh, wait.
Okay,
Yes,
so
I will have to hold it for you.
Really?
Because you
Okay,
both
fine.
step forward.
Okay, so hi, my name is Kai, and I'm going to show you a few of the features Paul talked about in live session. And so suppose I'm a new developer trying to onboard on a project written with using Izumi Framework libraries. In general, when joining a new project, you may want to try running the application or its tests first, because a lot of the time you may encounter roadblocks stopping you from running or testing, and you'd have to get help from your team members to stop the environment on your machine that would be sufficient to run the tests or the application itself. So let's see if we can. If setting up the environment will be very hard for
start on this particular project. So we see that we've started the tests after cloning. Some tests succeeded and some of them were skipped. Those that were skipped, they failed the integration check, and they did it because I do not have a Docker daemon running on my machine. So I'm going to start Docker. I'm going to start Docker and wait. Okay, I'm going to wait about a minute actually. All right. So now I have Docker on my machine, and I'm going to do the same thing again. All right, so the tests that were skipped before now pass. There are no canceled tests anymore. And this happened because DIStage has set up the environment for us, or a scene. It's set up for the tests. And to run the test, we didn't have to use Docker Compose, and we didn't have to run these Dockers manually. We just had to launch SBT, and we still have the test Docker that we used persisted. And we know it's a test Docker because it has randomized port. So we think it's a good improvement over regular onboarding experience. Many times we've seen developers spend hours or days setting up their environment, and with DIStage, if you set up properly, you can start hacking within minutes to join the project. So let's actually start hacking. What do I have? Right. So the project we have here is a simple leaderboard service. It allows users to submit their score. It allows users to get the state of the leaderboard, the users and their scores. It allows users to submit their profile details, and it allows users to query a profile for another user. And if that user has submitted a score, it will also add their score to the profile and add the rank position. So if they have the most scores, they'll be first in ranking. So we're going to look at the implementations of this service. So here we define HTTPS API that serves the /ladder part of the API. And
Who uses HTTPS? Quite a lot of people.
right, and this API actually delegates its implementations to this ladder repository component, which in turn has two implementations. One of them is a Postgres implementation, which carries an associated table and implements its persistence logic within it. And there is a dummy implementation, which carries its state in a functional reference in a ref that we create effectively right here, also in the constructor of this component. The entire project is written using Bifunctor tagless final style, using bio type classes. So we get provided capabilities such as the ability to make these refs, which we lose if we remove the type class instance. We also get functions to manipulate our effects, such as map provided by the functor instance. And we also get those without having to import syntax. So for example, for Ruby, we have to import syntax. But for bio type classes, we don't have to import anything except the names we used. And that works by, it actually works very simply. The name of the implicit conversion that provides syntax is the same as the name of the type class. So if you use a type class, if you write it in your program, you're also going to import the implicit conversions automatically and get syntax automatically. Since we're using tagless final style, you're going to have to write these, you're going to have to request those type classes a lot. So you're also going to get your syntax automatically. We call this technique implicit pruning, and if you're making a type class hierarchy, it's going to simplify the lives of your users a lot. And we also have the magic, or not so magic, we have the F summoner here, which gives us access to the functions provided by the type classes we summoned. Right, so we want to see how this dummy implementation of ladder works. So let's try to run our app using the dummy layer launcher. So you wrap a dummy, and we're going to launch the ladder part of the API. Right. I'm going to copy the curl, and alright, so we're going to add a score and then query the leaderboard. Alright, we got one score, and since we have a dummy instance, if we drop it and restart, we're going to expect that the score has vanished because it was stored in memory. And it has. Now we would expect the opposite to happen for a persistent implementation. So we're going to destroy the Docker we had before that was used for testing. And we're going to launch the application again with production implementation and with managed scene. Right, so we're going to add a score, get a score, restart, and get a score again, and we have it again despite restarting the application, so we are using persistent storage. And
No Docker components.
yes, so the scene management we use in our application is we're using the exact same code that we use in tests. We still have the persist container, but also note that the scene managed flag is not magic. It's not something, I mean, while it's defined in DIStage, it's not a magic pre-build. It's defined like any other, like you would be able to define any other flag. And it only works because we have this implementation that gets the Postgres details from a running Docker container associated with a scene managed flag. And we have another implementation that uses static details for Postgres set inside in configuration associated with the scene provided flag. So, oh. But we could also associate them with any other flag. And if we use the scene provided flag, it's going to try to connect to that Docker, which we don't have, because we have another Docker with a randomized port instead. Right. Now, this application is multi-tenant. It has multiple microservices or roles. It has another chunk of the API, which is the /profile API. And we may try running just that part. we're going to confirm that the ladder is disabled, and we're going to try to use the profiles. So we submit our profile and we retrieve that profile back. So so that way, when you have multiple rows and you have dummies defined for in your project, you may run perfect simulations of your product with all their integration points dummied out. It starts very fast and allows front-end engineers to code against it without maintaining a shared environment and without interfering with each other. Alright, so now let's look at the tests in detail. Previously, Pavel talked about the dual test tactic, and we used it at the start to run just part of our tests. So let's look at how it works. We have an abstract test suite. Alright. We have an abstract test suite. The suite summons dependencies using a function, a lambda. It doesn't know anything about the specific implementations of ladder that it will test against. We do not create this ladder anywhere. Only mentions of it are usages. Some of the tests here also use ZIO environment to request the components they use instead of using a lambda. So if you are ever wondering whether reader monad is DI, there's the answer. It's not. We use both reader and DI at the same time, and their use cases here do not overlap at all. DI is responsible for creating the object graph, while reader is responsible just for querying. So the use cases do not overlap. So here we have the concrete versions of the test inheriting from traits that just flip, that set a different activation. One repo dummy and another one sets repo prod. Setting the activation here is the same as using the urepo dummy flag in the command line, and I can demonstrate here. If I set this to repo dummy and I run the tests, we're going to use the same set of components for all of our tests, and we don't have any table creation messages here, so we're not creating the tables like you would for a Postgres test. And there's another helpful feature of DIStage test kit. It's memoization. So sometimes a component such as a Docker container or a database table or external integration would be too costly or cumbersome to create from scratch for each test, especially if there are lots of tests and they're all parallel. So usually people would hack around such as by using global mutable state in their tests to define a lazy valve somewhere and use it in all their tests. And then they would extend this hack and pile on more hacks if that one inevitably breaks or when their use case becomes more complicated. So DIStage solves this problem in a more principled way by allowing you to designate a set of components that will be shared across all tests. We call these components memoized, and they would only be shared across tests that are compatible. So it's not possible to get a memoized dummy component inside a production test, or vice versa. They're also shared together with their dependencies, so you cannot get duplicated components that are disconnected from each other. So allow me to demonstrate the problem with not having memoization. So I'm just removing this, and I'm going to run the tests again. Right, so the test failed, and the test failed because query letter DDO failed. Let me see. Right, so we failed while trying to create the table, and we technically we shouldn't be failing here at all, but we're trying to create the ladder table 5 times. We're doing this all completely in parallel, and Postgres just cannot handle that, these concurrent DDO changes, and it breaks. But even if it weren't breaking, there is really no reason for us to do this expensive global environment modification for every single one of our tests. We could just share this table between all of our tests. I mean, we are still doing that. We're just doing the creation request for no reason, and also breaking. So once we return normalization and kill the Docker container again, just to demonstrate that the creating tables again won't fail. Okay, we can see that instead of creating letters 5 times, we created 1 time. And the tests have passed without that concurrence here. We can also look at the log and see that we have 2 different memoization environments, 2 different small object graphs shared between our tests. So this one would be for dummy, and it only has a few components. And this huge graph supports running Postgres, running Docker, running everything. So it's huge. And they do not overlap, so we have different components for different configurations. All right. So that's it for testing memoization. Also, I want to show that despite a lot of features that seem magical, we run on GrailVM, and we use no. Oh, right, we just started. So we're running the GrailVM executable, and it just starts. And
I won't try to build it right now because it should take about like 3 or 5 minutes.
yeah.
Native image is slow.
And while the Scala 3 port is not quite there yet, it's already enough to run this test application. So we can also run with Scala 3. Yeah. With Scala 3. Okay, what do we have? Okay, whatever.
You already had pre-built process, so you may just clean and it will be visible.
Well, whatever. We changed the version, so we know Scala 3. Right. And last but not least, DIStage also provides compile time checks for your module definitions. So if you wanted to break something, like here, and recompile, that wouldn't work because yeah, we just removed the dummy ladder. We only have the prod ladder, so we know that we're missing a component. If we try to run with dummy tests, I mean with dummy repositories, it will fail, and we got that error while we were recompiling. So we know that our module definitions are correct, and they're also correct in all possible configurations at the same time. Yeah, now we recompile, and oh, and by the way, we didn't have to do a project or compilation or anything. It works with incremental compilation, so I'm just hitting F9 and it works. All right, so that's it, and that's it for a quick demo, and you may ask your questions if you have any. Thank you for listening.
Yeah, so there is one more, actually, I'm just going to connect my laptop again, show you the final slide, and that would be it. So there is a note. Compile time checks, they do not work yet on Scala tree. And actually he fixed the problem which prevented us from implementing working compile time checks on Scala tree, so it's going to be functional too soon enough. Yeah, where is
1 second. Is it this one? I think it's this one.
yeah, this one, yeah. 1 second.
Yeah.
Wait a second to think. Alright, so there are several links on the screen. The first link is for the repository with all the code of the demo Kai shown you. And the second link has a detailed glossary of all the terms specific to Izumi Framework. So please subscribe to our Twitters, give us GitHub stars, and by the way, as consultants, we are always looking for new challenges. So if you face a big challenge and you want to achieve the hyper productivity, give us a shot. We will help. And thank you for listening. And now it's time for questions, answers, and the rest of the meetup. Yeah, sure.
Thanks, Paul, for the presentation. Well, for those who is not familiar with your framework, it's quite fresh, so it was interesting. I have several questions to the concept itself, in general. You mentioned that you practice dual testing in order to, I don't know, maybe not to use Docker Compose and set up like locally part of the world and test on dummy implementations. Therefore, you introduce some kind of support of dual testing to switch different implementation of the same, right?
Yeah. No, actually, I guess I should clarify more because you kind of misunderstood me, but I'll clarify.
Okay, and therefore I have a little bit like question to that aspect in general. If it's quite simple to support some kind of protocols or components in the application, it's easy to create dummy implementation, for example, or stop some part of the implementation, right? But how do you think we should deal in case we use some managed external dependencies? Just an example, if we like introduce some authentication being done by external vendor, it's quite expensive to reproduce the same protocol, right? And flow. Could you elaborate a bit more?
Okay, actually, and there was a whole set of questions, and yeah, I'll try to make some clarifications and answers. So, first of all, the dual tests, we do not replace tests. We do not replace any tests against real integration points, against real external dependencies. We just allow you to write your business logic quicker, and we simplify onboarding. But
you can't just run your tests against dummies. You have to do both. What DIStage does, it makes it really effortless to run the same tests twice, because usually companies, teams which are trying to implement dual tests, usually they give up on this idea because it's hard to wire dual tests. It's hard to wire them in sound manner. And now to your question. So there are various kinds of external dependencies, and some are very hard to deal with. That's true. And I don't have a perfect recipe for doing that, of course. Though usually, well, from our experience, usually good abstractions, they always pay back. And when you implement dummies, you don't have to closely follow the protocol of an external dependency. What we usually try to do, and usually it always works actually, we try to build better abstractions. We try to reduce our dependency on an external component to a single interface or very small set of interfaces, and interact with these components only through these interfaces, and we try to make them as abstract as possible. And it's always possible to do that. That is another good aspect of dual test tactic. It enforces you. It enforces you to not over-depend on external models, APIs. It always makes you to create better abstractions, cleaner abstractions. So that's it.
Yeah, so
essentially, when you have to deal with an external dependency, like, well, or some kind of authorization provider, you try to first of all you should try to create a model, your internal model of which would cover your interactions with that authorization identity provider. And when once you have that model, you may implement a fake for it. Yeah. That's
yeah,
how,
so for
that's how
example,
it is.
For example, if you're using SQL and you're using it directly, instead of trying to make an in-memory implementation of SQL, you're going to use an interface to hide all of your instead of trying to create an in-memory implementation of SQL, you're going to hide your usages behind a repository, because having these queries in line inside your business logic code is improper, and having to create those dummies is going to show you that it's improper, because you will not have another way to progress other than move those actions into a separate interface. And the same would be for authorization, because is this authorization, is this part of business logic, or is this some kind of detail that could be hidden away? So if this is a detail that could be hidden away, it should be hidden, and it shouldn't be part of dummies, it shouldn't be part of interfaces. If it's not a detail, then you should have an abstraction for it. And this abstraction will help you test, and to help you test your assumptions, because you would have your assumption laid out in your dummy implementation, and you would have the reality in your production implementation. And when you test them both, if you have a discrepancy, if one of the test fails and the other test passes, that means that your assumption is incorrect. You have to correct your assumption. Moreover, you can also develop services with dummies first, which is easier to prototype without having to care about a lot of messiness of real integrations, and you can make a real prototype really fast, and then layer on the production implementations. So that's like the fact that that it's been hard to hide such details like an authorization protocol is the reason you would use dummies, because they're going to show you the parts where you're getting tied too hard to details that shouldn't. that shouldn't be everywhere in your code.
Yeah, so essentially we may reduce everything that was said to just towards abstraction and indirection. Are you happy with the answer?
Not so much, but I feel there was like a bigger topic to debate. It's not related to your topic in general, but the concept like how to test and how to develop may be considered from different aspects and different standpoints, and it may propose different set of receipts. Right?
This is a talk about how to develop because we are proposing some quite opinionated recipes. So while we are shown a framework, this framework also has opinions, or they are implicit in just the way that you would want to use something like a dual test tactic. And also the first part of the talk was also quite explicitly about designing things and shifting things left. So actionless is sort of the talk for it, I think.
Well, anyway, if you're unhappy with the answer, we might organize a workshop with our time. Maybe we may organize an online event. You may bring your problem or some kind of a mock-up problem, and we'll try to solve it online and show you the thinking process. I guess.
Or we can just talk.
Actually, if there would be no other questions, we may continue actually, or we may just continue in some kind of a private format. But would there any other questions? Oh, there is someone.
Question: How much does your tools depend on ZIO? Would using your tools put ZIO on my class platform?
No.
We support ZIO, but you do not have to use ZIO to use either of our libraries. So if you want to use our libraries with ZIO, you are very welcome. It is perfectly supported. If you want to run our libraries with Katz effect, you are very welcome. It is perfectly supported. If you want to run with Monix, it is the same. And if you don't want to use any IO monad, DIStage still can be used in such setup. And if you stick to Akka for some reason, you still may use DIStage, and moreover, you may find it very useful because it was always kind of a pain to create actors with dependencies, and DIStage it partially injected dependencies. There was I can't remember the name of that concept. But that's our concept. So essentially we have a tool, DIStage. It can create instantiate actors where some components, dependencies of are being injected from DIStage object graph, and some dependencies or arguments are provided ad hoc.
Yes, so neither of BO, LogStage, or DStage, or actually will bring ZIO or Katz effect or Monix or anything in your class path, despite supporting all of them actually.
Yeah, so as I said before, our libraries are loosely coupled. You don't have to use one component if you want to use another. And the same applies to our dependencies. You don't have, we do not enforce you to use ZIO if you want to use Katz. You may choose. Everything is composable. And DIStage itself is all about composability. Any other questions? No.
I have one more.
Oh, perfect.
the piece about roles and multi-tenant applications interesting, but I'm wondering how do you abstract over running a few components in single JVM or in separate JVMs, because either you call a method or invoke some HTTP client and so on. Do you abstract over that or?
So essentially, if you're talking about dependency convergence, when, for example, several roles depend on different versions
No,
of a
that's not
third-party
about it.
library.
That's not about
Okay, so it's not about convergence. So in that case, all the components are shared between roles. So for example, in case you have an HTTP server, Blaze server, it's going to be shared across all the roles. Actually that's precisely what we do. So usually we collect all the endpoints, into a set. We support the concept of weak reference set, and when our HTTP API role, it just exposes all the endpoints in that set.
That's about servers, but the question is actually about clients. So, for example, you have when you have a client of an API, and this API is in another microservice. But when you run them at the same time, you want this client to actually call your sublog.
Okay, I got it now. So it's a bit, your question is about interaction between components. Yeah. Okay. So you may have different implementations for your transport layer. So, for example, it's pretty easy to use local calls instead of HTTP calls if you launch two components together. Essentially, you just have to create an abstraction for your transport layer. Sorry, you just have to create an abstraction for your transport layer and select proper implementation for that abstraction, transport local, for example.
Yeah,
In your activation, yeah, like here. So actually, if you do that, it would be somehow beneficial for you, because for local calls, you won't have to involve serialization, deserialization, and deal with HTTP.
Okay, so for example, service discovery would be a concern of this production transport. And it's just not
yes. So essentially, you would have to write this abstraction yourself, but you'll be able to switch it on or off using DI.
Yeah. Well. Yeah, so essentially you create an interface for your transport layer. You create two implementations, HTTP and in VM, local, and you write your implementations. And also if you have some kind of a directory of your fleet of running services, or as you said, service discovery mechanism, probably you would have to tag instances to let your components know which components are running within the same process. Like it might help you to schedule some things better. Like, well, for example, it's a different story, but whatever. We have a stream processing engine which is wired by DIStage, and it may schedule it may schedule some steps, being aware that we would be executed on the same physical node within the same process. So it is like if there is a sequence of
Yeah, but that's not related to this.
Okay.
Anyway.
Let me finish. So if there is a sequence of steps which depend on each other. The scheduler might assign them to the same process which actually runs several components. I hope it was clear enough. Yeah. So essentially, if you have service discovery mechanism, most likely you would tag your services not only by the physical hosts they are running on or containers they are running on, but also by process ID where you're running in. Was that clear enough?
Yes, thank you.
Okay. Yeah, I've tried. Any other questions? Well, I guess that's it for now.
Thank you, guys.
Thank you very much.
Thank you very much. Okay, it's time for a networking break, sponsored by Sumo Logic. There's a pizza over there. There are beers in the fridge here and there. So yeah, enjoy, and we'll meet in half an hour for another presentation. Thank you. Okay, welcome back after the break. We'll be having a second presentation now by Michał and Aleksander. And I was thinking like how to introduce the talk, and I remember that people new to ScalaWAW often ask me like, okay, we've seen this monad of the month talk, but is there anybody actually doing anything interesting in Scala in production? So I guess this talk is gonna be that. And I hope we'll have more talks about actual Scala applications. Please welcome Michał and Aleksander.
Welcome everyone. So as Lucas pointed, we're using Scala in production. It's not the usage as you've seen in the talk before, but we will show today how we scaled our database from 1 million to billion of documents, and it will be about the Elasticsearch. Together with Oleg, will present more architecture talk, but I hope you will enjoy it.
Yep. Few words about us, so I'll start. I graduated from the University of Warsaw in 2017 with a master degree of computer science. 2 years later, I joined Sumo Logic here in Warsaw. And what's more, I used to be an algorithmic enthusiast. Privately, I'm keen on running and keeping myself in good shape. I run a few marathons, and I'm a father of a little boy. Thank you.
I also graduated from the University of Warsaw. I joined Sumo 2 years before Oleg. Currently, I'm an engineering manager, but I implemented a lot of stuff that we will present today, so I hope I will be able to show some technical aspects. I have more typical hobby for a software engineer. I like poker. So a few words about Sumo Logic. We are building actually cloud-native platform for observability and security. What does it mean? We started as a company focused on grab in the cloud. So basically, you can ingest any volume of the data to the cloud, and we'll provide you some tool for querying your logs, alerts, monitors, and so whatever you want to do with the logs ingested data to Sumo. We started in 2010 in California, in Redwood City, and then through the years we built more products, including tracing, APM, metrics, and also security. Here in Poland we have like 80 employees. 50 of them work from Warsaw. The rest is spread across the whole Poland. We have people in Zielona Góra, in Gdańsk, Krakow, Poznań. So basically, after pandemic, we started to hire remotely. And as I previously said, we are using Scala in production. We use Scala in version 2.13. Like more than 90% of our code is written in Scala. As I said, we don't use that heavily functional programming. Rather, we treat Scala as a syntax sugar over Java. But some places in our code also are monadic. And I have maybe a question. How many of you ever used SumoLogic product? We have one person, except Sumo employees. So basically we have this comfort that in Sumo we heavily use our own product. It's called dog fooding. So we as engineers are also the first line of using our product. We test a lot, so we use a lot. This is a sample dashboard created in Sumo to actually monitor Elasticsearch. We are using tracing, metrics, and logs. And I would say it's pretty awesome to work in a company that also use your own product. But on the other hand, you see a lot of more bugs. And over to Oleg about the actual usage of Elasticsearch in Sumo.
Yeah, going further to the main topic of our talk. Both me and Michał work in a metrics part of the SumoLogic platform, and metrics are basically about time series data. But metrics are not only about data points and timestamp, which forms the line you see at the dashboard, but they are also about some sort of textual data attached to them to be able to somehow distinguish between particular time series. For example, you want to be able to distinguish metric describing CPU usage from the one that tells you how much network traffic goes from one host to another. And at the very beginning of the metrics backend development, emerged a need for a full text engine that will be scalable and fulfill our requirements. So we basically want to tell you some sort of a story how our Elasticsearch setup evolved over years and how we managed to make it more and more cost effective and handle constantly increasing traffic. We chose Elasticsearch mostly for two reasons at the beginning. First of which is because Elasticsearch is built on top of Lucene, which was simply a state-of-the-art full-text engine at the time, and probably still is. And the second reason, probably even the more important one, that Elasticsearch was available as a hosted database by AWS, and we are a company running fully in the cloud in the AWS, so having a database that is hosted by our cloud provider was a big benefit for us. Yeah, going further, a bit about the setup of Elasticsearch that we currently run in metrics. As I mentioned before, we run Elasticsearch in AWS. Currently, we run it in version 6.8. Our clusters, some of them have 2 layers setup, which is in AWS called UltraWarm. it's very similar to what ElasticSearch calls, what ElasticSearch names as searchable snapshots, and we will cover it a bit more later in more details. We have 4 clusters that are 30 nodes plus size, and several other smaller ones. Our bigger Elasticsearch clusters have biggest Elasticsearch cluster have more than 50 nodes, and on it we store more than 200 terabytes of data, which is spread among more than 10 billions of documents. Few words more about how we organize the data inside the cluster. So, as it is very common in Elasticsearch world, our indices are partitioned over time, because metrics are time series data, and partitioning the storage over the event time is a natural way to do that. What's more, closed indices are fully immutable. They aren't written to, and the documents inside them are also fully immutable. What kind of documents we store inside our indices? Basically, the documents we store inside the index fall into two categories. First of which is which are active documents, and basically active documents mean that they are considered mutable and might be updated. And the second category is inactive documents, and they are already fully immutable. And like we will also talk a little bit more about it later. This is like to give a kind of overview of what we currently run. But it didn't used to look like that a couple of years ago. Over to
Yes,
Michał.
so let's go back 6 years ago, how it started. It started everything with a single index in Elasticsearch 2.3. So basically, we wanted to quickly run POC of some of the product, which is actually metric product, and due to simplicity, we basically chose a simple index where actually all documents were mutable. So we have one single huge index where all documents can be updated. And what is more, we didn't have any mechanism of retention. So basically, the index can grow a lot. You ingest new documents, the index started to be bigger. And if you know, most of the settings of Elasticsearch index are set up during index creation. So in this setup, you have a very little possibility to change your structure of mapping once you have the index created. So it worked initially, but as I said, the indices are growing basically indefinitely. So the index consumed more and more space. It's, I think, obvious. We needed to keep the documents for I would say, long time. So we face problems with space. But it's not only about space, it's also about the performance for the user. So we observed the bigger the index, the higher the query latency. So we stored the data from all customers in a single index, which means that the performance can be not that cool for all. The next problem about storing data in a single index that it's growing through the time is a shard size. So the number of shards is a static parameter that you set up during the index creation, and the rule of thumb recommended by the AWS and Elasticsearch is to have your shards not bigger than 50 GB. So you can imagine that the first solution that comes to your mind is probably how to partition the index. But as Oleg pointed, we have to deal with the documents that are active and non-active, and it was tricky to find easy partitioning over the time. We'll talk about it later, but just giving you the context that we have some non-trivial logic to solve at the beginning, and we decided to prefer the speed of development at this time. Plus, still we have to deal with million, not billion of documents. And a single index basically makes mapping adjustments impossible. So you can imagine that if you want to add some new field to your documents to enrich your search, you basically have to either rewrite the documents or maybe stop your ingestion. It was hard for us. I will show in a minute what we deliver as a temporary solution for this. And the last one problem is that some queries were timed out on Elasticsearch 2.3. At this time, we even have a situation when a single query with filters caused a whole staging Elasticsearch cluster to be down for a couple of minutes after running a heavy query. So later it turned out that Elasticsearch 6.x is better at handling filter queries. So temporary solution number one, how to rewrite the index. Still we are in the world where we have to deal with million, not billion of documents. So a procedure calling index migration was introduced. So basically we set up a new index with a different mapping next to the current index, and we basically doubled the ingestion. Why? Because the migration job can basically be not successful, and we are in the state where we have to back to the old index. So this procedure was kind of manually. We triggered a job called index migration. At this time, it was not, I would say, not the most parallel component of our system. So it takes literally days, even weeks for the biggest cluster to migrate the document. Plus, you have to also deal with a situation how to check that all your documents were successfully migrated. Plus, you pay the cost of double ingestion. So once all documents were migrated, we basically switched to the new index, and the old one can be deleted. And it was quite a painful procedure, but I can admit that we're able to migrate from Elasticsearch 2.3 to 6.3 thanks to this machinery, but it was a huge pain for actually the whole team.
Yeah, but like it allowed us to introduce changes in the running index. For example, when the shards got too big, we were basically able to migrate to a new index that have more shards or different mapping or does something else.
We didn't use like migration by storing all the shards in some S3. We needed a custom solution to rewrite the documents.
We couldn't do that because documents were mutable.
Yeah, plus this was also the case. And the second temporary solution that we have was called retention by deletion. And basically, we have to deal with indefinite growth of the index. But fortunately, some of the documents were basically outdated. So we stored some information in each document, the timestamp when the document started to be outdated. And thanks to this, we were able to introduce a periodic job called the deletion job. So it was a very naive job that basically went through all the documents and deleted the obsolete documents. And I must admit that we are kind of lucky here, because actually in Elasticsearch, a deletion of single document is quite an anti-pattern, because it's actually marking the document as deleted. And as long as the index is in use, is active, the documents marked as deleted are actually deleted in the background by force merging job. But once you close the index is not active, no one writes to it, these documents will not be deleted unless you run a force merge job manually. So this was the state like we started, but the key, I would say, architecture improvement to our setup that unblocked the further scalability was index partitioning that Oleg will present.
Yep, so these two sort of temporary solutions, not obviously not ideal, but they allowed us to iterate somehow and not like exceed the limits of the running infrastructure. But to be able to handle more load and introduce further improvements, we had to somehow figure out the way how we want to partition our data set over time, because as I mentioned, partitioning by time is quite a standard pattern in Elasticsearch world, and it allows you to consider like all the indices as closed and immutable, and with immutable data you can do much more. For example, you can leverage different kind of storage for them, or migrate them offline by using a snapshot and whatnot. What's more, like when you have closed and immutable indices, you can manage retention on a whole index level instead of deleting single documents. Finally, query has to scan less data. It has to touch only indices that intersect with the query time range instead of scanning whole data set. So in a common case of storing simple time series data in Elasticsearch, switching to a new index is fairly simple. At some point in time, you just start indexing data to a new index and close the old one. In our case, it was a little bit more complicated because of these two kinds of documents we have in the index, inactive ones and active ones. And the key assumption is that all active documents are present in the currently open index. So we couldn't just open new index, start ingesting new data to it, because we had to somehow first of all figure out the way how to move all the active documents to a new index, and what's more, how not to overwhelm the cluster with such a procedure. Because if we simply took all the documents and re-ingested them to a new index, we would simply kill the ingestion. So yeah, so we made our indices, instead of transitioning at some fixed point in time, we made them slightly overlap with each other. And during this so-called transition period, all active documents are gradually reingested to a new index. And once the transition period passes, we are considering the old index closed and immutable. And of course, we pay some price for this transitioning, because all of these active documents are basically duplicated across the two indices. However, we figured out that the amount of the documents that need to be duplicated is not that much, and we will be safe with that. Benefits from index partitioning. First of all, when you are able to partition your dataset by time, the index size stays under control. If the index is starting to be too big, if the shards are getting too big, you can just start a new partition, new index partition, and stop the growth of the previous index. Secondly, as I already mentioned, in a metrics world, there is always a time range tied to a query. So if you have a single index, then such a query needs to scan somehow whole data set, or at least some indices. When the dataset is partitioned over time, the query no longer needs to scan the whole dataset. Instead, it can only touch indices that intersect with the queried time range. Also, as I said, closed indices are fully immutable, which basically opens two possibilities. First of all, retention can be handled by dropping whole outdated indices instead of iterating and deleting single documents. And secondly, it opens possibility to, because the old closed indices are immutable, it opens possibility to use a different kind of storage for all their data and for all their data. The kind of storage that doesn't need to handle writes, it only needs to serve reads. What's more, by being able to switch the index seamlessly, we gained flexibility in the configuration, because a new index can be rolled with different mapping, different shard configuration, and different other settings, and it happens just like that. You don't need to migrate the whole dataset. Of course, old indices are kept with old configuration, but the index that is handling ingestion can be easily changed. Finally, index partitioning opened us an ability to shard a subset of our customers to a different index, or even a different cluster. It helps in situations where a big client, bigger than other ones, comes and starts to send a huge volume of data. Then in such situation, it is sometimes better to somehow isolate that client from others, to not let them interfere with each other. On top of the index partitioning, we also implemented some sort of automation, because at the beginning the process of rolling out a new index was manual, basically, when we observe the needs for opening a new index partition, we've been doing it manually, but it was a bit painful because we have several deployments, and doing such process on a single deployment is a bit cumbersome. It is easy. It is also a little bit error prone. You can easily skip something on or forget something. So ElasticSearch also has a sort of a plugin which is called index state management, and it is basically responsible for doing exactly that thing. The automation around rolling an index. However, this plugin was not sufficient for us because of this sort of a custom index transition logic, because this plugin is handling the common scenario very well, just like I mentioned, like creating new index and switching ingestion to it seamlessly, but it was not sufficient to handle our use case of the custom index transition logic. And as a result, we decided to implement a custom machinery, a set of fairly simple jobs that are responsible for rolling out a new index periodically and handling deletion of outdated indices. This solution helped us to solve a whole class of problems connected to the managing our data set. However, increasing product adoption was resulting in gathering more and more data, and we found ourselves needing to periodically upscale our infrastructure, our Elasticsearch clusters, solely because of a lack of disk space to store more and more incoming data. At the same time, the CPU on the clusters was running very low, and basically we were burning the money. What's more, the whole data set, even split across multiple indices, was stored on the same cluster. We didn't leverage the fact that all data tends to be accessed much less frequently in any way. So this was the point where the feature called searchable snapshots turned out to be helpful. And basically, this feature is called UltraWarm on the Elasticsearch run by AWS. But this looks to be the same thing. Few words about what searchable snapshots are and how they work. So in a standard setup, each Elasticsearch node has basically a volume attached to it. It is either a disk in the instance, or a network disk, or some other sort of a volume. Each node of the Elasticsearch clusters owns a set of shards from various indices, and each shard has a primary shard and a number of replicas according to configuration. And in such setup, there is no difference between storing like very recent data from the last day and the data that was ingested, for example, a year ago. All of the data resides on the same hardware. However, in the logs, metrics, and whole observability world, all data is usually accessed orders of magnitude less frequently than recent one. And what's more, expectations from such queries, for such queries are a bit different. If you are in the middle of an outage and try to figure out what's happening, you most likely want your data to be queryable immediately. Like you are, for example, want to observe the CPU of some of your hosts like now or in last 15 minutes, and you want that metrics to be available very quickly. Instead, when you are performing some sort of analysis on the old data, for example, from a couple of months ago, you are usually okay with waiting a little bit longer for such data to appear, and it is not such a pain like to wait a couple of seconds. ElasticSearch came up with a solution which is called searchable snapshots. And searchable snapshots let you use index snapshot to search infrequently accessed data and read-only data in a much more cost-effective fashion. Using this feature, you can use a different type of storage to store immutable closed indices. For example, it might be an S3 bucket or some other cloud-based blob storage. Because such a storage is not tightly coupled with Elasticsearch instance and is supposed to be fully persistent and reliable, there is also no need for replication. So basically, by moving an index from the so-called hot layer to a warm layer or cold layer, which is called in searchable snapshots, you can basically cut its size by all the replicas and store only primary shards. As I mentioned, a dedicated set of instances called warm layer or cold is responsible for querying shards from the underlying blob storage. And these indices in the warm layer are only partially mounted to the instances. Warm nodes use a sort of a local cache that contains only recently searched parts of the snapshotted index data. And all of these things are fully transparent to the user. Indices that are moved to a warm layer can be queried in exactly the same way as regular indices. So the setup is like fully transparent from the user point of view. The key benefit from such setup is that warm layer is able to store data a few times cheaper compared to the regular instances. To give you some example, I said that our biggest cluster of Elasticsearch has 50 nodes. However, without the ultra warm setup, it would have to run on 150 nodes to be able to accommodate all the data that lies on this cluster. Yeah, so this was about ultra warm. Concluding, Michał.
Yeah, so key takeaways from our scaling journey. So I would say, first of all, you don't have to set up your own database from scratch. If you are looking for a quick setup, you are launching a new product, you can use your cloud provider. In our case, it was AWS. That has plenty of database services, included Elasticsearch. In 2021, Elasticsearch forked, or AWS forked Elasticsearch to its own supported version and called them OpenSearch. So the newest version of Elasticsearch in AWS are available under a fork called OpenSearch. Second takeaway is that sharding your data in any NoSQL and big data world is a must. You cannot afford to migrate or rewrite your data. You have to partition them either by time or customer, and ideally both of them. If you are dealing with a million of documents, it was possible to run something like an index migration, but in the current scale, it's just impossible to rewrite the old data. And the last one, I would say it's quite challenging to work on a live system. It's whole new area of zero downtime. You have to support your customer. At the same time, all the customers are still ingesting the data, but it's very challenging and rewarding to see your system growing. And so we, as a Sumo Logic, we build a software for observability for our other customers. So we should pay even more attention to have our services running for all the time. And that's why we cannot sometimes use standard solutions. We need to figure out what to do to reduce downtime of any changes. And that's all. I hope you enjoyed the journey, and it's time for a Q&A.
Yes. Well, essentially, I guess I have 3 questions. And the first question, sorry, the first question is, so you said you were using Scala is essentially Java plus. Why did you choose it? Like nowadays, people unfortunately prefer to choose Kotlin when they need Java plus.
Yes.
So we started in 2010 as a company, and we started fully in cloud from day number 1 and fully in Scala for day number 1. And I know that it was basically an interesting language at this time. One of our co-founders thought that JVM environment is a good choice, and Scala was something new. We are a startup. Why not to choose Scala at this time?
We need to pass this question to our CTO.
Yeah.
And essentially the second question is like, you said that at least part of your code is based on some pure FP ideas. And what do you think about pure FP? Are you going to extend your usage of pure FP?
So if you are asking about using more advanced Scala code in the production code, I would say it's quite challenging for the new developers when you have to deal with a huge code base starting from day 1. And it's in some places where, for example, we are using parsers, there are more advanced Scala code, but usually we start to keep it as simple as possible.
Yeah, at some point when company grows to a certain size, it starts to, in my opinion, starts to be a little bit more difficult to hire talent that is like able to write pure FP than the imperative code.
Actually, I guess I would kind of disagree with that, and I would try to argue that there is a way to do pure FP in a very productive manner, and in a manner which would be easy for newcomers to adapt to. But I guess I would speak it for another time, and I have one more question, which might actually change everything. Have you ever heard about a company named Rapid7?
Could you repeat?
Have you ever heard about a company named Rapid7?
Rapid7? I don't think so.
Well, essentially this is your direct competitor. From what we read on your website, essentially you and you do the same job, mostly log analytics. So RAPID 7 will process like hundreds of terabytes of logs per day. And the second part of this question is, do you use or have you ever heard about probabilistic data structures, so-called sketches, like hyperlink hash, Bloom filter, cuckoo filter?
Some of them.
We've heard about
Bloom
filter data structure.
Bloom filters.
Yeah, so essentially RAPID 7 is a big company with huge capitalization, and it's all built around the idea of Bloom filter. So essentially it's not really, in their case, it's not really that important what's behind the probabilistic data structures, because they manage to do almost everything with sketches. And for like 80% of their job, they don't need to store gigabytes of data. They need hundreds of kilobytes. So like it may be a very productive idea for you to think about adopting probabilistic data structures in your flows. It might allow you to change, to save a lot, enormous amount of money if used properly. So it's more.
Usually our customers want to have all their data being
Yeah, you don't have to, if you don't have to use only probabilistic data structures, they work very well as a first layer in your design. You still might have a lot of independent like ElasticSearch clusters behind the first layer of probabilistic filters, and it may save a lot of money actually. It was more a suggestion than a question. Anyway, that's it. Thank you.
Thank you. Next one.
So thank you for the presentation. A very interesting case study. I'm enjoying. My question is related to software education, because you mentioned that you have two types of documents,
Yep.
active and inactive. Could you please elaborate on that? Because it seems to be one of the sources of the complexity that prevented you from adopting standard solutions. Could you please explain why and what's the use case?
Okay.
Sure. So
I can try to take it. So as I mentioned, we are developing the backend for the metrics product, and as you can imagine the metrics data is some sort of a live data, and as you can probably also imagine, ElasticSearch is sort of connected with the time series data we store. So at the very beginning, there were multiple vectors of the mutability of the documents across as we were implementing the optimizations and improvements mentioned during the talk, we were able to reduce the number of the sources that this mutability was coming from, but we weren't able to get rid of all of them. And some of them are still persistent, and they are very hard to get rid of. I'm not sure whether I answered your question enough, but maybe Michał can also add something.
yeah, so basically the key is that you don't touch the older documents. You can touch only the, I would say, newly ingested documents. Also some product constraints that we have are enforcing this. But basically it's not that typical, I would say, use case of the ElasticSearch, which is like you put the logs into the document. It's not about this.
Okay, so So I understand that these active documents are used for like storing metrics, and probably they are used to store some kind of current reading of the metrics, whether aggregated in some time we do, or that's kind of simplification.
Yeah, I think your intuition is correct. Not
full
okay.
metrics, but some part of them.
Yes.
So,
I'm just wondering because when you said metrics, I instantaneously thought about some time series DBs aimed for metrics like influx. And have you thought about, and regarding that question about active and inactive documents, and you said that there are some kind of vectors that cause that this is active document. Haven't you been wondering about like distinguishing which kind of data goes to ElasticSearch or elsewhere?
In fact, we are doing this.
Because I think that it's convenient to have like one place of the data, but that's very big, and if you somehow, let's say, divide it, it will be maybe less of them, but also you could, let's say, connect in both ways. I mean, both from influx to Elasticsearch.
It's a little bit hard question to answer in details because for sure we cannot go too deep into details. But what I can say that is that as you said, Elasticsearch is not our only database behind metrics product.
Yes, and what I can say that I cannot say too much, but that I think the key tip is that you access the latest data more frequently, and this is the key to, I would say, partition your data. Also across different databases. Any more questions? Okay.
You mentioned zero downtime for your application. How you handle switching between old index to new one?
So, as I mentioned before, we have a sort of transition time, and basically during that transition time, based on content of data being ingested, we decide which index to ingest data to, and this is like the zero downtime on the ingest path, and on the query path we basically have a time range for which we are querying the time series for, and based on the time range we can resolve the indices the query is going to.
I actually asked about the first migration from this.
Okay, I see. Okay. So the goal of this migration process was to try to keep these two copies of the index in sync, like achieve the state when they are completely in sync. So first thing was doubling the ingestion to old index and new index, and all the queries were still going to the old index. And by a migration job, you like gradually migrate all the remaining documents to the new index, and once they are finally in sync, then we reroute the queries to the new index and delete the old one.
Yes, so basically we kept the double writing for a longer time. Once the index will fully migrated, we still keep them for some short time. Then after we check that the index is migrated, we switch the query.
Yeah.
So the cost is like basically you have to pay the cost of storing the data twice and double ingest, which costs some CPU.
It's like, I think, fairly common pattern for migrating stuff. double the writes, and once the thing is in sync with the old copy, then route the query to a new copy and delete the old one.
Thanks for your presentation. When you were talking about offloading some old data that is not required to be part of code partitions or word partitions, is it something that is configured per client or per customer, or you have something more smart that consider patterns of data access and offloads and archive data based on these patterns?
Good question. So we are using a simple heuristic. Basically, it's time heuristic. That the older the data, after a certain threshold, we migrate the data to a warm layer, I would say. But of course, some more sophisticated mechanisms are possible. The index needs to be closed and immutable to be migrated to the warm layer. So basically, the hard requirement is to have the index closed.
Which shows like the simple strategy of having a fixed threshold, a configurable fixed threshold for all the data, because it's very easy to observe the query patterns on our site, and from such observations, like we came up that like fixed threshold will be good enough.
Do you use regular S3 for the data, or here to archive it and save some more costs?
So ultra warm, AWS ultra warm ties like the warm layer to S3, so it's based on S3. And the data in hot layer are stored on the instance disks.
And it's quite, I would say, a black box. If you're using AWS implementation of ultra warm, you basically don't care much about the how the data is stored. The same API for the queries are using to both query hot and warm layers.
I see, thanks. Why I'm asking, because some of products of AWS provides like smart capabilities of uploading data and archive it in order to save money for storage. That's why I'm asking. It may be like a little bit not straightforward to switch the storages, but it may be worth to consider at least. All the experts from AWS also constantly suggesting these products because it may save lots of money.
They're selling their products.
Well, they're selling, but the happier their customers are, the more benefit they can obtain.
Yeah, for sure. But we rather don't rely on such smart optimizations.
Any more questions? If no, thank you one more time.
Thank you.
Okay, thank you very much for tonight, but it's not the end. We're gonna head for a pint, or maybe more than one. We're having an after party at Uwaga Pivo. The link for the Google Maps location is on the meetup page, but also Tomek over there will lead you, and we have a reservation there, so yeah. I invite you to continue the discussions about ElasticSearch and Izumi with more beers. And thank you for eating all the pizza. That was a very great effort. Teamwork is very important. Next month.